Since the late 1940s, countries all over the world have sent all kinds of creatures and critters into the vast unknown, studying the physiological effects of microgravity, radiation, and high stress on living organisms. On July 9, 1946, a U.S. Army-launched V-2 rocket carried the first living organisms, a jar of fruit flies, into space. The United States used different species of primates for space research, and Albert II, a rhesus macaque, became the first mammal in space on June 14, 1949. More famous space monkeys include Miss Baker the squirrel monkey, the first primate to survive a trip to space in May 1959, and Ham the chimpanzee, the first hominid in space, in January 1961. The Soviet Union used stray female dogs, and on July 22, 1951, Dzyk and Tsygan became the first living creatures to survive spaceflight. The most famous space dog is Laika, a 3-year-old mongrel who on November 3, 1957, became the first living creature to orbit the Earth on board Sputnik 2. In August 1960, Belka and Strelka, as well as a gray rabbit, 2 rats, and 42 mice, became the first living creatures to survive orbital spaceflight. On October 18, 1963, France sent the first and only feline, a stray female tuxedo cat named Felicette, on a suborbital flight. In September 1968, the Soviet Union sent the first living organisms to the moon, the largest of which were a pair of steppe tortoises. 5 mice, nicknamed Phi, Phi, Fo, Fum, and Fui, flew to the moon and back with the Apollo 17 astronauts in December 1972. Skylab 3 in 1973 carried the first fish and spiders into space, and bullfrogs and newts were flown in the 70s and 80s. But we never really hear about the birds that made trips into space. Birds have been symbols of manned space exploration since the beginning. The Soviet Vostok spacecraft, with the exception of Vostok 1, which was Kater, or cedar, used birds as call signs. Vostok 2 was oil, or eagle. Vostok 3 was Sokol, or falcon. Vostok 4 was Birkut, or golden eagle. Vostok 5 was Yastreb, or hawk. And Vostok 6 was Chaika, or seagull. I've seen Gagarin's Vostok 1 referred to as Lastochka, or swallow, in American publications. NASA's Gemini 4 astronauts wanted to call their capsule American Eagle, and the Apollo 11 astronauts named their lunar module, one of the most famous spacecraft in history, Eagle, after the national symbol of the United States. Since the 18th century, the bald eagle has been a symbol of courage, freedom, and strength, and the birds are notable for their adaptability and resilience, trademark characteristics of astronauts. The Apollo 15 astronauts, all of whom served in the U.S. Air Force, named the mission's LEM Falcon after the United States Air Force Academy mascot. The SpaceX Falcon rocket family's namesake should be obvious, and Merlin, the engine family used by these rockets, is a species of falcon. Further, the astrobotic technology Peregrine lunar lander was named after another species of falcon. Several Soviet and Russian spacesuits were also named after birds, starting with the pressure suit worn by the Voskhod 2 cosmonauts called Birkut. It protected Alexei Leonov during his historic first extravehicular activity in March 1965. The Yastreb EVA suit was used only once during the crew exchange between Soyuz 4 and Soyuz 5. In January 1969, Soyuz 4 and Soyuz 5 performed the first successful docking of 2 manned spacecraft, but they lacked a connecting tunnel for easy internal transfer between the capsules. Soyuz 4 launched with 1 cosmonaut, while Soyuz 5 launched with 3, and 2 of the Soyuz 5 cosmonauts performed an EVA to Soyuz 4. The Sokol spacesuit has been the standard flight suit for cosmonauts since 1973 and is still worn today, and the Orlan, or Sea Eagle, has been the standard EVA suit since 1977. The Sokol suit was developed as a response to the loss of the Soyuz 11 cosmonauts. From Soyuz 1 in 1967 to Soyuz 11, except Soyuz 4 and Soyuz 5, the cosmonauts did not wear pressure suits during launch and reentry. Soyuz 11 cosmonauts Georgy Dobrovolsky, Vladislav Volkov, and Viktor Patsayev were killed from asphyxiation during reentry on June 29, 1971. The Kryche, or Falcon lunar EVA suit, and the Strij, or Swift pressure suit to be worn by cosmonauts on board Buran orbiters, never flew. The first avian space experiment was performed by the Soviet Union in February 1979. Soyuz 32, crewed by cosmonauts Vladimir Lyakov and Valery Ryumin, carried 8 fertilized Japanese quail eggs to the Salyut 6 space station to study the impact of microgravity on the development of embryos and to determine whether a Japanese quail could hatch and grow in space, serving as a viable food source for cosmonauts on long-duration missions. According to the Almanac of Soviet Manned Spaceflight by Dennis Newkirk, the space quails developed slower than the control grew on Earth, and some had no heads. From late September to mid-October 1979, the Soviet Bion 5 spacecraft, also called Cosmos 1129, carried biological and radiation physics experiment packages from multiple countries, including, perhaps surprisingly, the United States. In early 1971, the US and Soviet Union reached an agreement to cooperate in space biology and medicine, and in May 1972, the agreement concerning cooperation in the exploration and use of outer space for peaceful purposes was signed by the two superpowers and would ultimately culminate with the Apollo-Soyuz test project, the first international manned space mission, in 1975. American payloads frequently flew on Soviet Bion spacecraft, a program that focused on space medicine that flew 11 missions from 1973 to 1996. The Bion program is really fascinating and carried all kinds of animals into space, including the first Soviet space monkeys, but this video is about birds, so I won't go into those today. The American Bion 5 payload included rats, quail embryos, and plants. 60 Japanese quail eggs spent about 2 weeks orbiting Earth nestled in an incubator, but the shells of most broke upon landing. In the early 1980s, a 9th grader from Indiana named John Vellinger designed a science experiment to investigate how microgravity affected the development of chicken embryos. On Earth, eggs need to be turned frequently by a hen because gravity pulls the yolk down to the bottom of the shell. Vellinger wondered if a microgravity environment would change the way embryos needed to be cared for. He presented the experiment at the Shuttle Student Involvement Program contest hosted by NASA and the National Science Teachers Association, and won at the regional level 3 times. In 1983, when he was a high school senior, Vellinger's experiment won the national contest, so NASA began hunting for a corporate sponsor to provide funding for the experiment to fly in space. In 1985, when Vellinger was a freshman at Purdue University studying mechanical engineering, NASA arranged for him to pitch his idea to the fast food giant Kentucky Fried Chicken. They ate it up.
Oh, brother, this guy stinks!
KFC sponsored $50,000, and the partnership made more sense than you'd initially think. In 1985, the astronauts of STS-51F Challenger drank Coca-Cola and Pepsi from cans specially designed for consumption in microgravity. The experiment was part of a huge marketing campaign and the most publicized aspect of the mission, though personally I think the mission being the first and only abort to orbit of the Shuttle program is more interesting. Coca-Cola actually flew in space a couple more times in the 1990s, and a Pepsi commercial was shot on Space Station Mir during an extravehicular activity. It's only a matter of time before Dr. Pepper makes a trip to orbit as well. KFC's sponsorship of Vellinger's experiment, like Coke's and Pepsi's trips into space, would be a great advertisement of the company and its products, and show the public that KFC wasn't just interested in selling chicken, but also in science and space exploration. Chicks in Space, officially called the Student Experiment 83-9 Chicken Embryo Development in Space, sought to determine whether embryos could develop successfully in microgravity. We hope this will give us valuable data about embryo development under zero-gravity conditions, toward the goal of determining the feasibility of raising food sources in space, Vellinger explained in a KFC press release. Longer term, this can help us determine whether humans can reproduce in a weightless environment. In space, since there's no gravity, the yolk will be suspended inside the egg, which may make a difference in the way the chick develops. My hypothesis is that without gravity dragging the yolk down, the embryo will develop more efficiently, producing a bigger or better developed chicken. Chicks in Space consisted of 32 fertilized white leghorn chicken eggs nested in an incubator designed by Vellinger, now a sophomore in college and interning at KFC's Research and Development Lab in Louisville, Kentucky, and a KFC engineer named Mark Doiser. According to a KFC press release, the incubator designed to fit into one of the shuttle's lockers has a system of springs and shock absorbers, as well as temperature and humidity controls to protect the embryos from the vibrations and other effects of the shuttle's journey through space. It takes 21 days for chicken eggs to hatch, and the main embryonic development takes place during the first 11 days. The 32 spacebound eggs would spend 6 days in microgravity. They were split into 2 groups. Group 1 consisted of 16 eggs on day 2 of the development cycle, so 2 days after fertilization, while Group 2 consisted of 16 eggs on day 12 of the development cycle. The incubator's environment was to have the following conditions: a temperature of 99.5 degrees Fahrenheit, 65% relative humidity, 21% oxygen level, and 0.1% carbon dioxide level. An astronaut was required to open the incubator's hatch 8 times for 5 minutes during the 6 flight days to replenish the oxygen in the incubator. The crew member would write down observations in a logbook each time the hatch was opened, as well as the eggs' condition after launch and before landing. Bellinger would attend to control eggs back on Earth and turn them 5 times a day. Chicks in Space was to fly on the 10th flight of Space Shuttle Challenger, and payload specialist and soon-to-be first teacher in space Krista McAuliffe was in charge of the experiment. Her lessons were to be carried to between 80 and 90 schools that had satellite dishes, and available on some cable channels in the public broadcasting service. The Chicks in Space lesson plan was prepared by KFC in the science facility of the Louisville Collegiate School. It was an unusually cold morning on Tuesday, January 28, 1986, but STS-51L Challenger was given the go for an 11:38 a.m. liftoff. On board were Commander Francis Dick Scobie, pilot Mike Smith, mission specialists Ellison Onizuka, Judy Resnick, and Ron McNair, and payload specialists Greg Jarvis and Krista McAuliffe. 73 seconds after liftoff from Launch Complex 39B at the Kennedy Space Center, unfortunately, Space Shuttle Challenger broke apart and the lives of all 7 crew members were lost. So, since we're talking about birds in space and the Space Shuttle, I figured I'd mention this here. In the mid-1980s, NASA initiated the Space Flight Participant Program with the goal of sending non-government employees, in particular teachers, journalists, and other creative people, into space to increase public awareness of space exploration. Krista McAuliffe was chosen as prime Teacher in Space Project participant, and the Journal in Space project would have sent the first journalist into orbit in September 1986. One civilian in particular NASA was interested in sending into space on board Space Shuttle Challenger was Caroll Spinney, the actor, or more accurately puppeteer, who played Big Bird on Sesame Street. To make a very interesting story short, NASA reached out to the creators of Sesame Street, proposing to send Spinney, as Big Bird, into space to get kids interested in space exploration. But since the Big Bird puppet costume is 8'2", way too tall to fit in the orbiter's crew cabin, these potential plans were dropped, and the spaceflight participant program was terminated shortly after the Challenger disaster. I actually own the full Chicks in Space press kit that was available at the Kennedy Space Center on the morning of the Challenger disaster, and I used it a lot when writing this portion of the video. And since I feel so strongly about not only preserving space history, but making it accessible to everyone, I went ahead and photocopied everything and published it to my website. The link to these scans are in the video's description. Fortunately for Bellinger, NASA and KFC were still interested in his experiment and allowed him and his team to reconstruct and refine the incubator that was lost. The new Chicks in Space consisted of 32 fertilized broiler hen eggs. Like with the original, half the embryos were fertilized and incubated 9 days before launch, while the other half were fertilized and incubated only 2 days before launch. 3 years after the loss of Challenger and the original Chicks in Space, STS-29 Discovery launched on March 13, 1989, on a 5-day mission. Bellinger watched both shuttle launches from Florida. STS-29 pilot and Purdue graduate John Blaha operated the experiment while in orbit. Half the eggs from both incubation groups were allowed to develop fully back on Earth, while the other half were dissected. A week after the March 18th return, so after a full 21-day incubation period for the more mature embryos, the first chick hatched. He was named Kentucky and lived out the rest of his days at the Louisville Zoo in Louisville, Kentucky. All 8 chicks that hatched were from the batch of eggs fertilized 9 days before launch. No eggs from the group incubated 2 days before launch hatched. Once they reached adulthood, One of the space females mated with the space male and produced healthy chicks, indicating that time spent in space as embryos had no impact on reproduction. STS-47 Endeavour carried chicken embryos into space again in late 1992. After its trip to space, the Chicks in Space incubator was put on display at the Cosmosphere Museum in Hutchinson, Kansas. Bellinger and Doiser co-founded the Louisville-based company TechShot Inc., an engineering firm that developed biotechnology payloads for space-based research. Their devices flew on later space shuttle missions, SpaceX Dragon flights, and on the International Space Station. One in particular that is similar to Chicks in Space is NASA's rodent research hardware, which studies mice on board the ISS. Wow, look at those little guys go! Avian space experiments continued throughout the 1990s on board space station Mir. Mir is the Russian word for peace. On February 13, 1990, Soyuz TM-9 cosmonauts Anatoly Solovyev and Alexander Balandin arrived at Mir. Already on board was an incubator for quail egg research. A Progress M3 unmanned Soviet cargo craft docked with the station on March 3rd and delivered 33 quail eggs. 17 days later, on March 22nd, the first healthy quail chick hatched on board Mir and became the first bird in space and the first vertebrate to be born outside Earth's atmosphere. 8 chicks hatched in total, and initially, the baby birds could not feed themselves because they could not latch onto anything in the microgravity environment. Solovyev and Balandin had to feed the chicks themselves. The ones that survived were later euthanized, preserved, and brought back to Earth so their physiology could be studied. Soyuz TM-10 arrived to Mir on August 3, 1990, with 2 human and 4 avian passengers. Cosmonauts Gennady Manakov and Gennady Strekalov brought along 4 adult quails, 1 male and 3 females. One of the females actually laid an egg en route to Mir, and the egg was brought back to Earth when Soyuz TM-9 returned home on August 9th to finish incubation. Japanese quails have a typical incubation period of 17 to 18 days. And the egg hatched just fine. Back on Mir, the quails were equipped with little harnesses so they could feed without human help, but they showed no interest in mating. They were brought back to Earth with the egg by Soyuz TM-9 and had trouble readjusting to gravity. One of the hens even mated with a non-space quail and laid eggs, and the chicks that hatched were healthy. This was not the first time an animal that had flown in space had offspring. In 1960, Soviet dogs Belka and Strelka became the first living creatures to survive orbital spaceflight. Strelka had 6 puppies with a male ground-based space experiment dog named Pushok, and one of their puppies, Pushinka, was gifted to President John F. Kennedy by Premier Nikita Khrushchev. All of the space dogs were female, so it's possible others had puppies before Strelka, but the records of these dogs, their flights, and what happened to the ones that survived are incomplete. And this is different from the American chickens that reproduced with each other, since they flew in space before they hatched and not as adults. But then the Soviet Union dissolved, and space exploration changed forever. The Soviets, and as of December 26, 1991, the Russians, had Space Station Mir, the world's first modular space station, with plans for a successor, Mir 2. Mir operated in low Earth orbit from 1986 to 2001. The United States had plans for a modular station of its own called Freedom. It would have been a collaborative project between NASA, the Canadian Space Agency, the European Space Agency, and the National Space Development Agency of Japan. With severe budget restrictions jeopardizing both stations, and the Soviet Union now no longer existing, the US and Russia announced plans for a new space station, an international space station, in 1993. To prepare American astronauts for long-duration space expeditions and to get NASA and the Russian Space Agency used to working together was the Shuttle Mir program. 7 American astronauts carried out long-duration expeditions on Mir, and 9 space shuttle dockings rotated crew and cargo. Dr. Norman Thagard became the first American to launch on board a Russian Soyuz, Soyuz TM-21, and the first American to visit Mir in March 1995 as crew member of Mir 18. On April 11th, the Progress M27 cargo resupply vehicle brought 48 fertilized Japanese quail eggs that were incubated in the onboard Bulgarian-built quail incubator. Thagard became the first American to handle quail eggs in space. The embryos were preserved during different stages of development and brought back to Earth by STS-71 Atlantis, the first Shuttle Mir docking mission. Multiple batches of eggs were delivered to and retrieved from the station from 1995 to early 1999. Dr. Shannon Lucid spent almost 6 months on Mir in 1996 as a crew member of Mir 21 and continued quail embryogenesis experiments. The Shuttle Mir program ended in June 1998, and the first component of the International Space Station, the Russian Orbital Segment Module Zarya, was put into orbit in November 1998. While American astronauts no longer visited Mir, the station continued crewed operations until 2000. One of the last people to spend time on the station was Ivan Bela, the first Slovak citizen to fly in space. Czechoslovakia split into Czechia and Slovakia on December 31, 1992. Vladimir Remek became the first and only Czechoslovak in space in 1978, as well as the first non-American and non-Soviet citizen to fly in space. Bela arrived to Mir on Soyuz TM-29 with Commander Viktor Afanasyev and flight engineer Jean-Pierre Engrais, who would both be spending 6 months on the station on February 22, 1999. Some international cosmonauts missions had their own unique names. In fact, Engrais' long-duration mission was called Perseus. Bela's mission was called Stefaniak, after Milan Rostislav Stefaniak, a Slovak astronomer, aviator, diplomat, and politician who served as Czechoslovakia's first Minister of War and as a general in the French army during World War I. Bela's Slovakian experiment Prepelica SK6 continued research of Japanese quail embryogenesis. Prepelica is the Slovak word for quail. 60 eggs completed 2/3 of the incubation process on Earth, and Bela transferred them to the upgraded incubator waiting on Mir, Incubator T, crushing 4 of them in the process. A few days later, the first of 36 total chicks hatched. They had to be hand-fed, and unfortunately, the centrifuge broke down and the baby birds suffered in the cold darkness. 10 chicks returned to Earth with Ivan Bela and Commander Gennady Padalka on board Soyuz TM-28 on February 28, 1999, but only 3 survived descent. The next mission, Soyuz TM-30 in spring 2000, was the final crewed space mission to Mir, and in March 2001, the then largest artificial satellite re-entered over the South Pacific Ocean. Overall, the Japanese quail embryos and chicks on board Space Station Mir had a lower hatching rate and a higher rate of anomalies, such as abnormalities in the eyes, beak, and spine, when compared to control groups on Earth, though there were no significant deviations of body size and weight. If you're interested in the biological results of the space quail experiments, I've linked a paper discussing early development of vertebrates in space. American experience with quail embryogenesis on Mir was harnessed for the development of the Avian Development Facility, or ADF, quote, a habitat designed to provide environmental conditions optimized to study avian development in the microgravity of spaceflight, unquote. It made its maiden flight on board STS-108 Endeavour in December 2001 and was designed by John Bellinger and Mark Doiser of TechShot Inc., the minds behind the Chicks in Space experiment from the 1980s. The incubator contained 2 independently operated carousel platforms, and the egg holders on each could rotate a full 360 degrees to simulate the natural turning of eggs on Earth by hens. The interior humidity, temperature, and oxygen levels were pre-programmable. 36 fertilized Japanese quail eggs orbited Earth with the STS-108 astronauts, 18 on a stationary carousel for microgravity exposure, and the other 18 on a spinning carousel that simulated a 1G environment. 2 quail embryo experiments were conducted to study how microgravity impacts skeletal development and vestibular system development. The ADF's primary objective was the validation of its subsystems, and it performed nominally. As far as I've been able to find, STS-108's Avian Development Facility is the most recent avian space experiment, but there are a few more examples of birds and spaceflight I'd like to briefly cover. In May 1995, while Space Shuttle Discovery sat on the launch pad ahead of the launch of STS-70 targeted for June, pad workers noticed about 200 holes in the orange external fuel tank's insulation foam, ranging from little pecks to holes about 4 inches in diameter to claw marks. The culprit? northern flicker woodpeckers. The Kennedy Space Center sits on the 140,000-acre Merritt Island National Wildlife Refuge, home to hundreds of species of amphibians, birds, fish, mammals, and reptiles, including the northern flicker woodpecker. STS-70 was delayed until July, and the stack rolled back to the Vehicle Assembly Building in early June for repairs. Discovery launched on July 13, 1995, and deployed the Tracking and Data Relay Satellite 7 communication satellite. Kentucky Fried Chicken left Earth one more time in June 2017 when a Worldview Enterprises Stratolite high-altitude balloon carried a Zinger, a spicy crispy chicken sandwich, into the stratosphere. While the Zinger 1 mission was a more significant marketing campaign for KFC than Chicks in Space was, it was also a technology demonstrator of the new high-altitude helium balloon developed and used for communications, meteorology, and remote sensing. For now, this seems to be the end of the birds in space story. There is limited room on board the International Space Station for biological experiments, and rules for sending living creatures into space have gotten more strict over the decades. The Japanese quail experiments carried out by Space Station Mir's cosmonauts indicated the birds would likely not serve as a viable food source for space travelers during long-duration expeditions, since they had no interest in mating, trouble feeding, and the eggs had a lower hatching rate and higher abnormality rate. But it was also on board the station that the first vertebrae was born outside Earth's atmosphere. While Kentucky the Space Chicken and Mir's quails did not reach near the popularity that Laika, Ham, and Felicette have decades after their fateful trips into space, the avian space travelers contributed to our understanding of how new life adapts to microgravity and are trailblazers in their own small, unique way. Kentucky Fried Chicken's Challenger Chicks in Space press release said it best, quote, "When people begin living in space, they'll never ponder the age-old question of which came first, the chicken or the egg. In space, the answer will always be the egg." If you've made it to the end, thank you so much for watching, and I hope you learned something new today. This started out as a video about the Chicks in Space experiment specifically, but then I fell down a rabbit hole of avian space experiments, and almost a month later, here we are. As always, my bibliography can be found in my Birds in Space web article linked in the description, and if you want more space history, hit subscribe, and I'll see you next time. I've been Erin, and you've been watching Spaceflight Histories.